edge in computing and cloud in computing. So cloud is right now so many people using. So long time ago we just using for standalone so computer, but computer power is right now developing. So many people using cloud system. So I just this paper just present just introduce cloud computing and edge computing. So my field is that automobile field. That is why this is concept, and then I just implementation in my field as well. So I think all of our students and the audience know about this software as a services SaaS. We call SaaS. So I think right now Salesforce is so powerful tool for SaaS as well. And when I was in enterprise at the time, I used for SaaS solution as well. And usually we had a contract with Oracle for ERP, Oracle, and using SAP is just one time fee for 1 year. But right now they made a subscription uh, model, so SaaS model, and that they subscribe their fee on monthly basis. So I think right now for students also they using Google Workstation and another solution as well. They using it, so we call the SaaS. So I think so many big company they try to change their business model to SaaS right now. And same as SaaS, so many company using their last infrastructure as a services. So Amazon and Azure in Microsoft, they try to give a server to audience, and then they will use their infrastructure, and they have to pay for that using fee as well. When I was a Hyundai Motor Company, so we made a server in United States, in Korea, and another states. At the time, we used a standalone cloud system. For example, United States and Russia and China and Europe, we made a four data center based on cloud. And when we made cloud services in India and Saudi Arabia, we use for uh, Azure services and Amazon services. So we use a hybrid system. Why? Because when we have private data, we should save in our private server, and then when we have some public data, we are using uh, Amazon, AWS, and Azure in Microsoft. Why? Because first time, if we make a new server, we have to pay for a lot of infrastructure and uh, their software as well. So big country, for example, United States and China and Europe. So we made our own server. And uh, in Russia, they have a regulation. If we are providing new services in Russia, we should establish our server in Russia territory. That is why we made a server in Russia and we provide the services. That is why it's a different method, different concept for making a server, such as infrastructure and SaaS as well. And today, so we have uh, a lot of services require for high speed, require for low latency. That is why so many company they using cloud etching service. So when I was in Korea, I'm using Kakao voice recognition. Kakao server is Kakao company server is, for example, in Jeju Island, but I'm using in Seoul. It has a long distance. At the time, Kakao company they made a etching computing system in Seoul, and then they reduce the latency. So this kind of concept, so a lot for uh, voice recognition system. And today I just give some uh, example about automobile as well. Automobile also right now they have a voice recognition. So nuance in United States, in Europe, for example, when you get into the car, if you are asking something to your car, it's usually based on nuance in like a Siri in Apple phone. So we are using it, and then they using a cloud system. They using a etching etching computing as well. This is a example for the my paper. So as I told you, it's the multi-tenancy and scalability. So we can use it. And then so right now, it's a purple Salesforce in the wall CRM system. So I think Nike and car manufacturer they selling their car and they selling sports goods. That's all. But right now they have some sensor. They have some kind of communication tool they have after finishing uh, sales, and then they want to communicate each other, communicate from OEM as a manufacturer and uh, and for example seller with customer. So Salesforce they have a solution as a software system. For example, when you get into the uh, airplane. So when you get in, and then Salesforce they have some software right away. They asking about the satisfaction with airplane, and then if they have some kind of the poll or some kind of questions, they gathering the data, and then Salesforce their software giving some solution to the uh, uh, for example, Korean Air and Asian Airlines, something like that. So they giving some kind of solution as well. Um, and PaaS is also platform as a services right now. And then they also, as I told you, Azure in Microsoft. So Microsoft they giving so many kind of the lectures. They giving us some certification for using Azure services, and Amazon as well. They make a platform. If I using Amazon platform, so they give a portal, they give a platform. I can make a cluster there, and then I can manage my project for their services, and then they also selling for platform as well. And as I told you about the infrastructure, so infrastructure example is that so if I want to make a server in India, first of all, I don't have enough. My customer is a small size of business is okay first, and then if I good at my business in India, I can scale up there, so it's easy. But if I invest a server in India, oh wait a minute, yes, yeah, okay. India right away is a bunch of big money. So I don't forecast my subscriber as well. That is why it huge risk. That is why if I invest my server, is based on customer use at the time. So Hyundai company, Hyundai Motor Company, they tried to get a Amazon or some Microsoft their infrastructure they were using. And when I was in Russia, when I was in Europe, so in Frankfurt, we had some rule, GDPR, is that so I have to make us own server in uh, European country. At that time, we have a branch office in Germany. That is why we made our server in Germany, and then all uh, information saved in Germany, even though it's even though, for example, EU country, Spain, Italia, and another big countries. So we get the all data in Frankfurt there. But when I was in Russia, at the time, I used a Microsoft solution, but infrastructure is just a Russian uh, all standalone our server, standalone our physical environment because they have a regulation. If I yeah, if I providing my service, I have to establish all server in Russia. And I use Microsoft platform. That is why from UK, from another European market, so Microsoft employees uh, came to Russia, and we set our server, our platform in uh, Russia. So infrastructure is a standalone, but PaaS, platform as a services, are using by uh, Microsoft, and then software was Microsoft. We use it, this kind of thing. This is the last. So class method is a last pass SAS. It is also new field. It's 120 or 10 years ago. So many company made this concept, server storage network and operation system and the software. Yeah. So you can see that. I just cover the instruction. So hybrid cloud, as I told you, private and public. So when I went to the uh, European market, so it's a hybrid cloud. Why? Private cloud. We have a data about the vehicle location using GPS, using cellular network. We use the Vodafone cellular network. At that time, we gathering all data in private cloud. It's as I told you in Germany, so we serve all data in Germany and private cloud, and then we collecting data, customer data also private cloud because based on regulation. So at that time, we think about first regulation from the government, and then we save the data in uh, Germany in private clouds, and then except personal data, we are using private clouds because public cloud because they have some solution such as platforms, such as software, and then we gathering the non-private data. We collecting the data in private cloud, and so private and public. So we exchanging each other their uh, databases. And then when we using some cloud system, sometimes we had a difficulty with uh, interfacing their databases. Sometimes they have a error as well. They have some problem. At the time, we use uh, our backup system. In, for example, Germany, we have a sales office, and Czechia. So we had a factory there. So we have a backup system, recovery system. Sometimes Germany server has down, so Czech in Praha. So we backup system. This is also good benefit for uh, uh, hybrid cloud as well. And analyzing analysis of clouding computing and edge computing cloud systems classify the public cloud, private cloud, and community cloud and hybrid cloud. So this is concept. Public cloud is a customer enterprise and a network security and database and storage is public cloud. So I just call public cloud by Amazon Web Services is public cloud. Uh, okay. What is edge computing? Uh, so why you are using? Because of their factory. For example, semiconductor, their line is so important. If they stop during 30 minutes, a lot of loss they have. That is why edge computing system is good for them as well. And then for car, is right now a Waymo in Google. They are no driver, and then they taking their customer in San Francisco and Los Angeles right now. They have own services. It's based on clouding services. But if they don't have edge computing technology, so if they have some problem, they disconnect their network, disconnecting their some cellular network or network. They have a big problem. That is why they has to have so edge computing technology. So traffic information and the radar sensor and the radar sensor they collecting the data and then they detection and then they so drive that smoothly. So they there is why they're using edging computing right now as well. And then let me see that. So this architecture is that is a cloud data center and the center data center and interconnected data center. They have a connection each other. So as this is example, for example, I'm living right now in LA. My server is Florida. It's such a long distance. At the time, we make a data etching computing data and the interconnected data center in LA, and we are using. So etching computing using for the ship, using for the airplane, using for some web, some fast food company, and then emergency uh, emergency car as well. So edge data center over there and the gateway and the devices, smartphone and tablet and laptop. You can see that there uh, management system there and then scanning. So it's a warehouse is a scanning there and the sensor and the beacon and Bluetooth and the IoT is computing. So edge computing refer to the distributed computing paradigm that process data and a near source service generation rather than relying on centralized data center and clouds. So aim to reduce latency is most important thing. What's the matter is the reduce latency and enhance speed, improving performance by bringing computation and data storage close to end user. So as I told you, voice recognition and the recognition of the traffic, recognition of the customer size is so important for the yeah edge computing by minimizing the need for data to travel long distance. Edge computing facilitate the real-time processing, which is especially critical in applications that require immediate response. So as I explained about semiconductor line is so important, and then some manufacturing line is so important for their latency and their connection at the time they're using edge computing as well. So let me give us some example about edge computing on more detail. So this area is a left side, and then so energy, wait a minute. Energy management and software engineering and auto scaling, resource management, security and privacy, software defined network and big data analysis, data science, deep learning, and serverless computing is an emerging research area. It's a 2022, some research there. And then uh, IoT is that they have a 5G and data processing, cloud container, and the QoS, and then pro computing and quantum computing, application design, the fault tolerances. So AI and blockchain, IoT, so they consist of the cloud computing as well. So edge computing is not extension of cloud computing, but also pivoting a technology that shape the future of data processing. There is place in the world, which is getting smarter day by day in the faster, smarter, and multilateral system is country to globe. So let me So I have more time, and then I'm gonna give us some kind of the cloud computing mode. I think cloud computing is right now so popular from the Amazon. So many people using AWS, and then AWS wants to have a application. That is why so many employee stuck to their company, big company. So they give us some kind of the educate. They have some solution, and then they providing. So on automobile industry as well, if they have application, they gathering the data, they present to the another OEM such as Ford or Honda and Toyota and Tesla as well. They gathering some data about the cloud computing and then selling as well. That's why I think cloud computing system by uh, uh, Amazon and Microsoft and Google as well. And then, so in automotive market, it's Amazon is number one. Number two is Microsoft. But I think Amazon is 80% of the market share they have for their vehicle market. So, and then, so transitional architectures, I think all of you know that is transitional architecture is there like when you have a laptop, just your laptop, it's no cloud, not connect to the another clouding system, just your laptop. It's same concept, it's a transitional architecture. So if I have a laptop here and then own data server there, and that's all is a transitional architecture. It's a reliable, it's I think a little bit higher security because I using just one laptop. Data sensor, power supply, cooling maintenance, so on my own. Okay, clouding system. Uh, Usually they said the lower IT cost. Why? As I told you, if I set up my server in, for example, Europe, if I don't know about my subscriber will be 1 million, I don't know that. But sometimes reach to the high volume. At the time, I have to invest memory, invest my server, invest my infrastructure. At the time, it's a high bunch of money I have to put there. But if I using hybrid cloud system, usually I put a small amount of money and then scale up. I'm adding my money and then uh, uh, more investments. So usually cloud system is a lower IT cost, but reality is that cloud system also take a lot of investments. When I was there, and then I put first of all making a cloud system. It's based on setup fee. It's based on worker. So employees fee. Employee is a software development fee. The period of their development. That is why a standalone is like a transition architecture. Is for example 1 million, for example, dollars. But so first of all, cloud system is half of the 1 million, but time goes by, I have to put money for the cloud system the same as transitional architecture. So it's for my case, but another case I think so many research papers say there's a lower IT cost, but reality is that it takes also high cost. Improve agility and time to value and scale more easy and cost effective. And the on-demand means that you can scale up, you can scale down. It's possible for using a cloud system and broad network access and resource pooling and left it, and then measure services. Why cloud? So many company they think about the reduce their cost. This is why they wanna using a cloud system, and then a cloud system gives more flexibility. As I told you, scale up, scale down is more easy. They are using their technique as well. It's more flexible. That is why they're using it. So when we using a public cloud, we try to reduce infrastructure cost. That is why we are using cloud system. And then high scalability. Yeah, yes, increase computer and the memory capacity of the server. That's why we are using a cloud system. And then let me see that. So I covered the PaaS, I covered the SaaS and public cloud. Okay. This trend for the cloud system and edge computing. And then right now, so many company spend more public cloud system after pandemic. Because as I told you, if I use AWS, first initial pay is uh, not that high. That is why using AWS first, so reducing their cost. And then multi-cloud and hybrid cloud will have so downtime worries. So multi-cloud, hybrid cloud. So as I told you, so even though you are making a cloud system, you have to make a recovery server as well. So uh, when we have a shutdown in Germany and Praha, Prahi's, they have a own server, they recover each other. Container technology will slow but steadily gain the popularity. The virtual desktop will become more, yes, it's a mainstream. So when you're using your laptop, when you're using a slide and sheet. So I think so many people using a Google Sheet, Google Slide right now. So right now, so Microsoft to lose a lot of market share as well. And then they change their subscription basis for 365 for Microsoft Teams and their PowerPoint and Excel is mainstream right now. Security technologies involved to become a cloud native and acting first. Okay, and the communication, collaborate with the important cloud use cases. And serverless computing will be the exciting adaptation area. So I think next, my research paper is a serverless architecture. I think so. It's a new field, I think. So that is why I gonna focusing on that field as well. And companies are stronger to keep cloud budget in check. Cloud is power, let's spread AI adaptation. Yes, AI. So next lecture, so I just covered it, AI as well. Why AI is so important? As professor mentioned, that detection cancer as that is based on databases. So right now we are using a cloud system. We get a lot of data, and then we detecting the data as well, and then it has some optimization based on high computing power. So right now we have a great performance for the AI services right now. So that is why cloud helps to improve AI solution right now. Yes, Azure is a Microsoft is a second follow for the AWS. So right now growing, and that they give a more educational some pre-trial for their customer. They are growing right now. So automotive market also uh, they are actively they sell their solution, giving their more interactive. There's customer and their technician as well. Yes, right. This is trend. That's all for my second paper for edge computing. And so right now, I'm gonna give you the lead thinking requirement analysis for AI-based services. Before that, so I'm a little bit giving my bio. So right now I'm in United States. I'm teaching computer science at Pacific State University and California State University. Uh, I finished a PhD in Korea, and I right now I'm exchange professor in United States. So right now I'm focusing on medical plus mobility as well. That is why right now I'm project is that collecting the data. So for example, drivers behavior. Someone is sleeping. Someone has some difficulties. Some, for example, senior, they have a lot of problem in their driving. So with detection from my some kind of simulator, and then I just gather the data is the eyes data, their handle data, and the vector and skull as well, and then we analyzing using uh, algorithm, and then we providing uh, services to customer as well. For example, senior drivers they have some problem about uh, when they have problem when they driving. So right away that data goes to their son or daughter. So your mom and dad right now some problem. They are three times their handle, their steering wheel is changed right now. So be careful, your dad and mom. and this data goes to the primary doctor as well. So in United States, they're using Elation. They have a portal there. Is they have some pop-up system. So if I and my patient has a problem and when they're driving, so it's pop up to the primary doctor's website, primary doctor's Elations over there. And then that system is that when they have a problem, it's direct go to the 911. It's connecting them. So in Europe, they have that system, PSAP. So when they are crashing their car, its signal goes to the PSAP, such as 911, and then they directly go to the death side as well. So this kind of concept in United States. So when they have some problem, it signal goes to the 911 in Korea as well. So we made some system. When they have some problem, it goes to the police office, goes to the ambulance, this kind of the uh, response system as well. That is my all my right now my field. Rethinking requirement analysis for AI basis product. So today I covered agile software developments. I covered that AI basis projects, requirement analysis. Why? So last semester I taught them software engineering. At that time, we made some topic. So one topic is the requirement analysis. Requirement analysis is that it's a principle in software engineering there. So when we are receiving the requirement from the customer, they have a two factor. One factor is from the user requirements, and second factor system requirements. When I was Hyundai Motor Company, at that time I was engineer. I have to gather requirement from the marketing side and sales side. They want to make a sales portal. They want to make a marketing portal. They want to make some website for the customer. So at that time, I gathering from their user requirements. So and then they said that I want to make a that field. I want to make that field that field. I gathering the data. So I was a product manager in R&D side, and then I made a criteria. I made a standard over there, and then I have to send it to the infrastructure guy. I have to send to the uh, platform guy. I have to send it to the software guy, and then making a system requirement, a breakdown system and the user, how many end user they have, and the clients, engineer and system architecture and software developer. As I told you last section, so we made a Scrum on my R&D side, and then I made some kind of the schedule and then input and output, and uh, so we share about this one to the marketing side and sales side based on AI tools. This kind of requirement specification, I usually do that. And then they have some kind of functional requirements, non-functional requirements study. It means that it takes money or not. So uh, we have to distinguish with that requirements, user requirement, and system requirements. So this is lecture side, and then me and my students made some letter, made a paper. Is that? So as I a little bit introduce a requirement engineering, it's a software engineering. Is inside of that they have a requirement engineering. Uh, in my case, for example, yeah, For example, when we making a portal in enterprise, long times ago, same as for example waterfall methodology. We made this portal. That's all, and finish. But right now, it's it's easy to change their requirement. They change about their uh, because as I told you, we made a mic, micro development. So divide their function basis, login and services or platform, and they have separate databases, separate architecture, separate software. So that is why if my customer, such as marketing side and sales side, they giving me a requirement changes, it's easy to change it, easy to fix it. And then when they have some question, I'm making a scrum, and then we communicate each other, and then we fix it. This kind of system we did. So what is requirement? Requirement engineering is process that involve analyzing, specifying, validating, and managing requirements of the system. It takes a long times ago. So that is why my paper giving some idea and the framework also for progress. So you can see that after this one. And then objective of requirement engineering is to ensure that the resulting system or product meets needs of the expectation of stakeholders. So it's more important. So meet their needs and expectation from your customer. High quality and delivers on time within budget. It also involves managing the requirement throughout the development process. Effective requirement engineering is a credential to success software engineering project. Okay, as I touch this one. Okay.